In this video, you will learn how to test hypotheses for difference between two population means. We always start out with asking whether the population from where the sample come from, is it normally distributed? If the answer is yes for both, then the next question to ask is whether the population variance is known. So do we know the population variance for both population? And if the answer is yes, then we will have a sampling distribution of the difference between the sample means will be normally distributed, and that we can use the test statistics as follows, which is x bar 1 minus x bar 2 minus mu1 minus mu2. This will be the hypothesis value divided by the standard error, and the standard error is square root of sigma 1 square over n1 plus sigma 2 square over n2. Now what if we do not know the population variance? Then the answer is that we have to use a t-distribution, and the test statistics will be 2, 1 when the population of the two samples are not equal, and number 2 when the variance of the parents' populations for the two samples are equal. So if it's not equal, we have to use this test statistics, x bar 1 minus x bar 2 minus mu1 minus mu2, the hypothesis value, divided by square root of s1 square divided by n1 plus s2 square divided by n2. But when the population variance is assumed to be equal, then x bar 1 minus x bar 2 minus mu1 minus mu2 divided by the square root of sp squared, where sp squared will be the common variance, call it pooled variance, multiplied by 1 over n1 plus 1 over n2. So these are the three types of choices that we have depending on the situation. Now what if the population is not normally distributed? Then there are two cases. We have to ask whether are both sample sizes greater than 30. If they are greater than 30, if the answer is yes, then we can fall back to the central limit theorem and we start to ask again the same questions. So you have three choices of test statistics to choose. But when the sample is less than 30, then we have to revert to use non-parametric approach. Now let's look at the example, the first example here. The distributions of wind speed in Casper, Wyoming and in Phoenix, Arizona has been found to be normally distributed. The average wind speed was calculated for a sample of 31 days for each city. The results are reported below. Is there sufficient evidence at 5% significance level to conclude that the average wind speed is greater in Casper than in Phoenix? These are the sample statistics, and this you are also given the population standard deviation. Of course, here the test statistics that we are going to use will be these test statistics. We know the population variance, and also the sample come from a normal population. In testing the hypothesis, here we are interested whether to know one of the mean is greater than the other, and this is how we set our hypothesis. Under the null hypothesis, the test statistics will be 12.85 minus 7.9 divided by the standard error given by 3.3 square divided by 31 plus 2.8 square divided by 31, and you'll find that the test statistic Z will be 6.3682. At alpha 0.05, since this is a one-sided type of test hypothesis, it will be on the right. So the area here will be 0.05 and the critical value will be 1.645. And we'll find that the test statistic is inside the critical region. Therefore, we reject the null hypothesis at 5% significance level. Conclusion, there is enough evidence to conclude that the population mean of wind speed in Casper is greater than in Phoenix. Let's go to example number 2. Example number 2, a real estate agent wishes to determine whether tax assessors and real estate appraisers agreed on the values of homes. A random sample of the two groups appraised 10 homes. The data are shown here. Is there a significant difference in values of homes for each group? Test at 5% significance level. Assume that both of the populations are normally distributed. Now these are all the information from the sample, and we have a small sample size here. So here, first of all, it doesn't say that the population variance is the same, but population is normally distributed. So the test statistics that are related to what information is given to us will be the t-test statistics with a degree of freedom. So we have to calculate this degree of freedom using the formula. Yeah, this one here. You can see that the degree of freedom will be equal to S1 square divided by N1 plus S2 square divided by N2 square that divided by S1 square N1 square N1 square that all divided by N1 minus 1 plus S2 square divided by N2 and then square that divided by N2 minus 1. This is the degree of freedom that we have to use, and in this particular problem we will find that the degree of freedom will be equal to 16, and we proceed with writing down the hypothesis. We only want to see whether there is any difference, and let's calculate the null hypothesis. So the test statistics will be equal to 83,256 minus 88,254 divided by square root of 325 square divided by 10 plus 2341 square divided by 10, which is equal to minus 4.0185 at alpha 0.05, and t distributions at 16 degree of freedom. You'll find that the critical value is plus minus 2.921. So on the right side and on the left side will be, one is positive, one will be negative. Okay, that is the critical region there, and we know that minus 4.0185 is inside the critical region on the left side. Therefore, we reject the null hypothesis at 5% significance level. Conclusion: there is enough evidence to conclude that there is a significant difference in the values of the homes between the two groups. Let's go to in example 3, the Journal of Biogeography, Study of Ants in Mongolia. Botanists place seed beds at 5 sites in the dry steppe region and 6 sites in Gobi Desert, and observe the number of ant species attracted to each site. Is there evidence at 5% significance level to conclude that a difference exists between the average number of ant species found at sites in 2 regions of Mongolia? Assume that the populations of ant species are normally distributed, having similar variance for both regions. So here you will find that what is given to us is that the populations for both data here are normally distributed, and the sample size is quite small. For dry steppe you have 1, 2, 3, 4, 5, and for Gobi Desert you have 1, 2, 3, 4, 5, 6. So this is a small sample size, but the populations come from normal distribution. And again, the variance is the same, assuming to be the same for this problem. So the right test statistics is simply x bar 1 minus x bar 2 minus the hypothesized value mu1 minus mu2 divided by square root of the pooled variance sp squared multiplied by 1 over n1 plus 1 over n2, and this we will have to compare it with a t distribution with n1 plus n2 minus 2 degree of freedom. From the sample, the statistics will be as follows. Sample size for dry step is 14, Gobi is 11.8333, and the sample standard deviation is 21.3073, and for Gobi it is 18.2145. Now with that information, let's calculate the pool variance, and the pool variance is given as follows. 4 multiplied by 21.3073 square plus 5 multiplied by 18.2145 square divided by 4 plus 5, and the answer is 386.0926. Coming back to the problem, let's write down the hypothesis. We are interested that they are different, so the alternative hypothesis is testing the mean of the first population is not equal to the mean of the second population. Under the null hypothesis, the test statistics t test, which is 14 minus 11.8333 divided by square root of the pool variance multiplied by 1/5 plus 1/6, that will give you 0.1821. And at 9 degree of freedom, we will find that at alpha 0.05, the critical value will be on two-sided. One will be on the negative side, the other one will be on the positive side, and the value is 2.262. So you will find that the test statistics will be outside the critical region, and hence we fail to reject the null hypothesis at 5% significance level. Therefore, the conclusion is that there is not enough evidence to conclude that there is a significant difference in the number of N species between the two regions. Let's go to example number 4. Example 4. Each year, the state of Kentucky invites bids from dairies to supply half-pint containers of fluid milk products for its school districts. Data on all bids received from the dairies competing for the milk contracts during a period of time produces the results in the table below. Is there enough evidence to support that the mean bid prices in the tri-county market is higher than the mean bid prices in the surrounding market? Test at 1% significance level. And these are all the sample data given. It is a large sample here for both samples, and the sample mean is quite close. From the tri-county, it is 0.1431. For the surrounding market, it is 0.1331. And these are the standard deviation. Let's write down the hypothesis. So we are interested to see whether the mean, population mean of one is greater than the population mean of the other particular population. Under the null hypothesis, the test statistics, you can replace this t with z, although by right it is the t distribution, but because of the large sample size, you will see that the t distribution will be almost as good as the standard normal distribution. So with that, we will find that the t statistics is 6.0283, and going back to the standard normal, you will find that at alpha 0.01, the critical value is 2.326. So this is a test on the right side, and the area will be here 0.01, so the critical value 2.326, and you will find that the test statistics will be inside the critical region. So therefore, we can reject the null hypothesis at 1% significance level. Conclusion: there is enough evidence to conclude that the mean bid prices of white milk in tri-county is significantly higher than the mean bid prices of white milk in the surrounding market. So that's it for the test of hypothesis when you are looking at differences between two population means. And thank you for watching.